Hey everybody, this is Mr. G again, and welcome to another mini lesson. Today we're going to be talking about potential versus kinetic energy. By the end of today's mini lesson, students should be able to define and identify potential and kinetic energy, and then also explain the relationship between potential and kinetic energy, which is going to be very important to understanding these types of energies. What you're going to need for this lesson is going to be a sheet of paper, preferably lined, and a pencil. I'm going to give you a moment to go and grab those things. When you're done, I want you to click continue. All right, so the essential question for today is, what is the relationship between potential and kinetic energy? What I would like for you to do is I would like for you to write the essential question at the top of your lined paper, just as I modeled for you on the right side. Go ahead, I'll give you a few moments to do that. When you're done, click continue so we can begin. All right, so we're going to get into our notes on potential versus kinetic energy right now. But before we get into our notes and we take notes, let's just pause for a second and talk about energy and what it actually is. Energy is literally the ability to do work. Everything in the world that moves, everything that you can see, right? Everything in the world that happens, it happens because of energy. So, if there were no energy, there'd be no light. You wouldn't be able to see anything. Everything would be black. If there were no energy, there'd be no heat. It would be so cold you can't even imagine. If there were no energy, nothing can move. So energy is literally the thing that makes the universe go round. And most of the time, we can't see the energy. We just can't see it. But it's still everywhere around us, which is very interesting to think about. All right, so before we get started, just copying your T-chart, just like the T-chart on the right side of the page. I'm circling it right now. Your vocabulary word on the left side and your definition on the right side. Go ahead and then we'll move. All right, so the first type of energy we're going to talk about here is potential energy. And what potential energy is literally stored energy. Okay? I want you to circle that. So when we get into our notes. But for now, it's stored energy. There's two types of energy. There's gravitational and chemical. So let's go over to our pictures to the left. Right here, that's showing gravitational. And that is gravitational potential energy. Because gravity is what's causing the ball to have energy in the first place. Let's break it down. When the ball's up here and it's suspended by whatever it's holding it up, that ball has potential energy because gravity is pulling on it. When that is released, that ball converts its potential energy into kinetic energy, which is what we're going to get into in a second. But when it's staying still, it still has potential energy because it's high in the air. If it got higher, it would have more potential energy. If it gets lower, it would have less potential energy. So the higher the ball goes, the more potential energy it actually has. And specifically, the more gravitational potential energy it has. Now, this over here is a good example of chemical energy. Now, this is a good example of chemical energy because it's gasoline. And you know that when you see a can of gasoline or if you see gasoline in a pump, it just sits there. It's not moving. It's stored, right? Even though it's stored and it's not moving, doesn't mean that there's not energy inside of it, because you know that if you lit a match next to that gasoline, it would erupt in a fire. Because it has so much energy stored inside its molecules. In the chemicals that make up that gasoline, there are so much energy. And that's why it is stored energy, it's potential energy. So even though things aren't moving, doesn't mean that they don't have energy. What I want you to do is I want you to copy in the definition, the vocabulary word, potential energy, and then the definition. I want you to circle the word stored, because we know that potential energy is energy that's not yet moving, but is stored and has the potential to move. Go ahead, copy it in, and when you're done, I want you to click continue. All right, let's do a quick check here. I'm going to read the question. I'm going to give you a few moments to answer, and then we'll go ahead and go over it. At which point A, B, or C, actually there is no C, so we'll X that out. At which point A or B does the roller coaster have the most gravitational potential energy, and why? Is it point B, because the roller coaster is traveling the fastest? Is it point A, because the roller coaster is moving the slowest? Is it point A, because the roller coaster is at its highest point? So remember, we're not only talking about which point, all right, so which point, A or B, does the roller coaster have the most gravitational potential energy? We're also talking about why, so we have to get the explanation correct. I'm going to give you a few moments to break down this question, and then I want you to answer it, and we'll go over it afterwards. Go ahead, try it. All right, let's go over this. So at which point, A, B, or C, does the roller coaster have the most gravitational potential energy? So first off, I'm going to circle right here, gravitational potential energy, because we know that that has to do with the height of something, how high up it is. The higher up, the more gravitational potential energy it's going to have. And it says A or B, so let's just circle the points. So which point, A or B, does the roller coaster have the most gravitational potential energy? Well, let's go through question A, or answer choice A. Point B, because the roller coaster is traveling the fastest. Traveling the fastest, did that have anything to do with the amount of potential energy it has? Because remember, potential energy is stored. If it's moving, that's not potential energy. So we can slash that one. Point A, because the roller coaster is moving the slowest. So when we talk about moving the slowest, was that what we said was an indicator of having gravitational potential energy? I don't think so, but let's read the next one. Let's see if the next one makes more sense. C, point A, because the roller coaster is at its highest point. What did we say that gravitational potential energy had to do with? Well, it says highest point here, and we said it had to do with the height. If it's higher up, it's going to have more gravitational potential energy. Therefore, we know that C is our answer because it's the highest point. All right. Let's get into the next type of energy we want to talk about, and we're going to keep it real simple right now. Kinetic energy is energy in motion. All right, so motion is the key word here. Anything that's moving has kinetic energy. That's not just objects, that's things like lights. Heat can move, sound can move. These are different types of energy, and we're going to get into that the next lesson. But let's just talk about kinetic energy, and let's remember it as the energy of motion. So just to show you here, this pendulum, right, that's swinging from side to side here, all right, at the top of its root, it has a lot of potential because that it actually briefly stops at the top of its root. So potential energy as it gets higher. When it gets lower, it starts to speed up. All right, so as it gets lower in its root, it starts to speed up, and therefore it has more kinetic at the bottom. So as you can see, kinetic and potential energy can transform from one to the other. Potential can go to kinetic, and kinetic can go back to potential. Let's go ahead and make this copied in. When you're done, just click continue. And I want you to circle the word motion. All right, so this is what I want you to do. This is a very similar question to the first one, but what I want you to do is I want you to answer it because this one is talking about kinetic energy. So I'm going to read the question to you. At which point A, B, or C, does the roller coaster have the most kinetic energy? Why? Point B, because the roller coaster is traveling the fastest. Point A, because the roller coaster is moving the slowest. Point A, because the roller coaster is at its highest point. I want you to go ahead and I want you to try this question and then we're going to go over it. All right. So at which point does the roller coaster have its most kinetic energy? So we know that that's the energy of motion. So we have to look at point A or B. I know that point C doesn't exist. I don't know why it was in there. So let's look. Point B, because the roller coaster is traveling the fastest. So when you say traveling the fastest, does that have anything to do with kinetic energy? Well, since kinetic energy is the energy of motion, and if we're traveling fast, we're in motion, that seems like it could be a plausible answer. But let's look at the other choices just to make sure. So we're going to put a maybe next to that, an M. All right, B. Point A, because the roller coaster is moving the slowest. So if we're talking about moving the slowest, if it's the energy of motion, if it's moving slow, is it going to have a lot of that energy or a little bit? We're looking for the most kinetic energy. Therefore, that cannot be the answer. Let's see, point C, letter C, point A, because the roller coaster is at its highest point. Well, the highest point had to do with the gravitational potential energy. Does that have to do with the amount of kinetic energy? No. So A, point B, because the roller coaster is traveling the fastest. Remember, if it's moving fast, it has a lot of kinetic energy. If it's moving slow, it has a little bit of kinetic energy. If it's not moving at all, it has no kinetic energy. All right, let's do another quick check. Because I know that I talked about how potential and kinetic energy can actually transform one to the other. Well, let's just go back here. Before you answer this question, I just want you to see from point A to point B. So at point A, we have a lot of potential. A lot of potential energy because we're at our highest point. But as the roller coaster starts to drop, we start to move faster, and that potential energy transforms into kinetic. All right? But then as we go back up, that kinetic energy then transforms back into potential. And basically, you'll see that potential and kinetic energy can transform between each other very easily. So let's go ahead and try this. As the man is throwing the watermelon from the top of the building, what energy transformation is happening? I want you to try this. Is it potential to kinetic or kinetic to potential? Try this question and we'll go over it. All right. So as the man is throwing the watermelon from the top of the building, what energy transformation is happening? Now this is a big word. Transformation. Energy transforming from one form to the other. Well, let's think about this. First off, when the man's at the top of the building, what kind of energy does that watermelon have before he releases it? If you were to say gravitational potential, I'm sorry for my handwriting. So as it's at the top of the building, it has a lot of gravitational potential energy, right? Now, when he drops that watermelon, all right, so we're going to say when he drops the watermelon and drops it down, it starts to move. So that gravitational potential energy is now converted to what type of energy? If you said kinetic, you would be correct because it's traveling faster and faster and faster as it falls. So our answer here would be potential to kinetic. Because if you're dropping downwards and gaining speed, that's going to be potential to kinetic. Now, let's say that he took the watermelon and he carried it up the stairs. So he went up. Say the watermelon didn't break somehow and he went back up with it. He's moving upwards. So now he's taking that kinetic energy and he's transforming it back to gravitational potential because he's moving upwards. And the higher the watermelon gets, the more potential energy it will have. So let's just end this off by copying our last thing, which is the law of conservation of energy. And that states that energy cannot be created or destroyed, just transformed from one form to another. We just talked about how potential energy and kinetic energy can transform between each other. And that's illustrated right here in this pendulum, which I explained earlier. As the ball gets higher, it has more potential. As it gets lower, it gets more kinetic. And it just continues to transform between kinetic and potential. Right here, with this fire right here, there was chemical energy inside of the wood. All right, inside of the wood, there's chemical energy. That is potential energy. Now, that energy is not destroyed. When you put the fire on, it literally transforms that into heat, light, sound. So the energy is not disappearing, it's just taking a different form. And that's the law of conservation of energy, which means we still have the same amount of energy that when we begin and when we end. They just take different forms. They don't disappear or destroyed forever. All right, what I want you to do is I want you to copy in your last word, which is the law of conservation of energy. And I want you to circle the word cannot be created, destroyed. Go ahead, copy that. When you're done, click continue. All right, so we are going to do our last question right here. This is the toughest question we're going to do all day. Let's see how we do on it. It's going to be challenging. Harry uses a pulley to put up a bucket of water from a well, or to pull up a bucket of water from a well. That should say pull. He uses chemical energy in his body to apply mechanical energy to the system. Which of the following energy transformations also occurs as the bucket rises? Energy is gained as potential energy is transformed to kinetic energy. B. Energy is gained as kinetic energy is transformed to potential energy. C. Energy is conserved as potential energy is transformed to kinetic energy. D. Energy is conserved as kinetic energy is transformed to potential energy. All right, go ahead, take a moment, and when you're done, we will go over it. All right, so let's go ahead and circle the keywords in here. So he talks about here using chemical energy in his body. So using chemical energy in his body to apply mechanical energy to the system. Then it says which of the following energy transformations also occurs. So whatever happened in that previous sentence really isn't that important to what's going on. And then another keyword is the bucket rises. So let's just think about now what we talked about when we said that watermelon. If you were to take the watermelon and drop it off the building, that was potential to kinetic. But if it rises, that should be kinetic to potential. Now, I'm not going to write the whole thing. I just want you to sorry. There we go. That should be kinetic to potential. All right. Now, so what we can do here is let's go ahead and let's eliminate the answers we know are not true. We're looking for kinetic to potential. So C says it's conserved. Potential energy is transformed to kinetic. Because we know that the bucket rising is going to transform kinetic to potential. Also, A, energy is gained as potential is transformed to kinetic energy. So A and C, both of those say potential to kinetic. And we know those won't work. So it's between B and D right now. Energy is gained as kinetic energy is transformed to potential energy. Well, we know it's kinetic to potential. Let's look at D. Energy is conserved as kinetic energy is transformed to potential energy. The only difference between those two are the words gained and conserved. If you looked at your last notes, you'd know that energy, due to the law of conservation, energy is conserved. It's not gained, it's not destroyed, it's not created. Therefore, B cannot be the answer. The answer would have to be D, due to that law of conservation. If you got that one, I'm proud of you. If not, it's okay, as long as you understand the explanation. All right, let's wrap up this lesson. I want you to go ahead and answer the question, what is the relationship between potential and kinetic energy? I want you to think about what we talked about in this video. Rewind it if you have to, and use your notes. Go ahead, answer this question, and I'm going to leave it there. I appreciate you all. Thank you for being here, and I'll see you next time on Mini Lesson with Mr. G.